LSA Pump Overview. GIW High Performance and Low Maintenance LSA Series pumps consist of three major sub-assemblies: the wet end assembly, the shaft seal assembly, and the mechanical assembly. The mechanical assembly of the LSA pump is composed of the pedestal frame, which supports all other parts of the pump, and the bearing assembly with the shaft. The cartridge bearing assembly is interchangeable from pump to pump of the same design and size. If several pumps use the same cartridge bearing assembly, GIW recommends a spare cartridge bearing assembly be kept on hand. The shaft seal assembly can be either a split stuffing box assembly or a single or double mechanical seal. The wet end assembly includes parts of the pump that come into contact with the slurry and consist of the suction plate, suction liner, impeller, and shell. Larger sizes may also include a hub plate and separate hub liner between the shell and pedestal. Shells on most GIW pumps do not have feet. This allows the shell to be rotated to different discharge positions. The impeller is a single casting with a suction shroud, hub shroud, and multiple pumping vanes. The suction plate is a non-wear component that holds the suction liner in position and provides for attachment of the suction piping. The suction liner is a wear component made out of a wear-resistant white iron. An O-ring or snap ring gasket is used to seal the suction liner to the shell. A nomenclature sheet pointing out the various pump parts and design features is included in the maintenance manual for easy reference. When ordering GIW pump parts, please use the proper pump nomenclature and also include the complete part number. Pump drive. Once the pump is placed on the foundation, but before the drive and piping are connected, verify that the motor rotates in the correct direction. To verify this, switch the motor on with the drive component disconnected. The direction of rotation must correspond to the direction indicated by the arrow on hub side of the pump shell. Once the rotation is correct, connect the piping and drive equipment. If the impeller rotates in the wrong direction, even momentarily, it may unscrew and severely damage the unit. If a variable frequency drive or other controller is used, it is recommended to permanently disable reverse and brake function during controller setup. Under no circumstance should the pipe system be equipped with a check valve or other device that can rapidly decelerate the flow rate. Mechanical assembly maintenance. The rolling element bearings of the LSA mechanical assembly are splash oil lubricated. The oil level in the bearing housing should be in the center of the sight glass when the pump is not operating. Bearing housing oil capacities are listed in the maintenance manual along with oil approved for use in GIW bearing assemblies. Perform the first oil change after 50 to 100 operating hours, then every 3 to 4 months thereafter. To change the oil, remove the threaded plug and drain the used oil. Once the assembly is drained, reinstall the plug and fill with fresh oil as described in your LSA maintenance manual. Limited end float arrangements are available and recommended when using a mechanical seal. Contact GIW for additional information on limited end float bearing arrangements. Overhaul of the shaft and bearing assembly is also covered in the LSA maintenance manual and is also available at any GIW region service center. Stuffing box maintenance. The shaft sleeve has a fused carbide coating for extended wear life and is a slip fit onto the shaft. The shaft sleeve is held in position between the impeller and impeller release ring or held by a flange on the inner diameter of the shaft sleeve. The stuffing box provides the seal along the rotating shaft sleeve and prevents slurry from leaking back along the shaft. GIW uses 3 types of stuffing boxes. The most common is the standard forward flush design, which has 4 or 5 rings of packing and a separate lantern ring ahead of the packing. The second type is the KE design or minimum dilution stuffing box, which has 2 rings of packing ahead of the lantern ring. This minimizes the flow of sealing water into the pump. The third type is the throat bushing stuffing box. The throat bushing replaces the 2 front rings of packing and the lantern ring to convert the KE design to a forward flush. For most applications, GIW recommends using the standard design. The KE design should only be used when water supply is limited or minimum seal water dilution is absolutely necessary. With either type of stuffing box, proper alignment must be maintained with the shaft sleeve or uneven compression of the packing will occur. The proper method of alignment is to loosen the bolts, remove the packing, then measure the distance between the shaft sleeve and the inner bore of the stuffing box. The holes in the stuffing box mounting flange are drilled oversized to permit moving the stuffing box for alignment. Measure at 4 different spots, 3, 6, 9, and 12 o'clock positions. The 4 measurements should be the same. If they are not, adjust the stuffing box until they are uniform. Then tighten the bolts that hold the stuffing box to the pedestal. GIW stuffing boxes have a replaceable wear plate. The inner bore of the wear plate is made only slightly larger than the outside diameter of the shaft sleeve to maximize the velocity and flushing action of the seal water entering the pump. Should wear occur on the inner bore or front face of the wear plate, it can be replaced by removing the shell or stuffing box. The stuffing box packing should be changed each time the stuffing box begins to leak excessively or during a major overhaul of the pump. To change the packing in a pump, you must remove the nuts holding the packing gland to the stuffing box. The packing gland is split and can be removed from the shaft completely or moved back against the bearing housing. The packing is removed with a packing puller. Replace the packing and lantern ring in reverse order, making sure to stagger the joints so that they are not in alignment. Separator discs are used between each row of packing to improve packing life by providing more uniform compression to all rings of packing. Make sure the replacement packing is clean, dry, and cut on an angle. To ensure proper maintenance of the stuffing box, we recommend the use of GIW packing. It is pre-cut to the correct length, sealed, and protected during shipment. The stuffing box gland nuts should be hand tightened. Over-tightening the gland may cause the packing to burn up after startup. After the pump is in operation, the gland may be tightened further if necessary to maintain a small, steady stream of water flowing out of the stuffing box. The stuffing box is equipped with tapped holes for sealing water. To keep the stuffing box free of abrasive particles, the sealing water pressure and gland tightness should be adjusted to maintain a small flow of cool or lukewarm leakage out of the stuffing box. If the leakage becomes hot, the gland should be loosened to allow greater flow. If the leakage becomes cloudy or you experience low packing life, increase the water pressure. The sealing water pressure required to maintain satisfactory stuffing box operation depends on pump operating pressure, slurry properties, condition of the packing, clarity of the seal water, and the type of stuffing box. In general, a supply pressure of 10 to 15 psi over the discharge pressure of the pump should be available. This can then be adjusted with a valve to lower pressure as needed in actual operation. The seal water requirements for the different size pumps are listed in the maintenance manual. Wet end maintenance. For effective operation of your GIW pump, a minimum impeller nose clearance must be maintained. The impeller nose clearance is the gap between the suction liner and the machined strip on the impeller suction shroud. If the clearance is too great or not uniform, recirculation of slurry around the front shroud of the impeller can cause accelerated wear to the suction liner and impeller. The impeller nose clearance is adjusted by axial movement of the bearing assembly using the adjusting screw. If the pump is equipped with a mechanical seal, consult the mechanical seal manual for axial alignment requirements. Initially, clearance should be checked at 4 locations, the 3, 6, 9, and 12 o'clock positions. Once the pump is in operation, it is not necessary to remove the suction piping. The pump is adjusted using the adjusting screw with the following procedure. First, loosen the bearing housing hold-down bolts. Second, using the adjustment screw, move the bearing housing, shaft, and impeller forward until the impeller contacts the suction liner. Third, place a mark on the pedestal opposite the mark on the bearing housing. Fourth, using the adjusting screw, back the bearing housing off to the proper clearance for the pump. This measurement can also be taken using a dial indicator or match marks on the pump. Spin the shaft 1 complete turn to ensure that it rotates freely. The last step is to torque the bearing housing bolts to the required torque listed in the maintenance manual and also shown on the plate attached to the pedestal. Failure to tighten the hold-down bolts properly can result in severe vibration and damage to all pump components. Wet end part replacement. Since the wet end parts come into contact with the slurry, they are subject to wear and will need to be replaced periodically. Generally speaking, the suction liner will need replacement first, then the impeller, then the shell. In addition, the O-rings and gaskets must be replaced whenever the wet end parts are replaced. The new suction liner is attached to the suction plate by lowering the suction plate onto the suction liner and installing the studs. Before installing the suction plate suction liner assembly to the shell, a new snap ring gasket or O-ring must be installed. The snap ring gasket is an important part of the pump assembly and can greatly affect the life of other components. There is only one correct way to install the snap ring gasket. The word outside must face out with the thick edge of the tapered gasket against the suction plate. If the gasket is properly installed, it will snap back into position when pulled out and released. The pump shell side opening is tapered at 10 degrees to provide proper seal of the suction liner to the shell. The tapered area should be carefully cleaned before installing the suction plate and liner. Slowly slide the suction liner into the shell. Because the opening is tapered, there is a wedging action when the nuts are tightened. Tighten the fasteners using a cross-torque technique to maintain proper alignment as parts are pulled into place. Ensure that the suction liner and impeller are never in contact when bolting the suction plate to the shell. As the suction liner moves into the shell, the gasket is compressed and part of the gasket will protrude into the inside of the shell. During pump operation, the slurry wears away the part of the gasket that protrudes into the shell, providing a smooth joint between the shell and the suction liner. This smooth joint eliminates turbulence and minimizes wear at the joint. If a gasket is used that has been in service, it will not be compressed sufficiently to protrude into the shell. GIW recommends a new snap ring gasket be used each time the suction liner is removed. If a new gasket is not available, a 1/4 inch O-ring or similar backup material can be placed between the snap ring gasket and the suction plate. This will provide compression of the gasket into the shell. During normal operation, the impeller becomes tightly screwed onto the shaft by the running torque. To remove the impeller on a pump equipped with an impeller release ring assembly, evenly loosen the main fasteners that hold the release ring segments together. Thoroughly clean the threaded holes along the outer diameter and insert push-off bolts to free the segment from the shaft. The push-off bolts should be threaded in the same amount of turns to ensure the ring segments are pushed off evenly. Once the segments are removed, the impeller will unthread from the shaft with little resistance. During reassembly, be sure to clean all parts and use extra strength fasteners specified by GIW to hold the segments together. The fasteners must be installed with Loctite 242 and to the torque values listed in the maintenance manual. Never reuse any impeller release ring assembly fasteners. If the pump does not use an impeller release ring, an impeller break loose jig can be used for impeller removal. The break loose jig is attached to the trailing edge of an impeller vane and prevents the impeller from turning when the shaft is turned in the opposite direction from which it normally operates. A mild yet sudden jolt to the shaft will disengage the impeller. Once free, the impeller can be removed with a GIW impeller lifting jig. Before installing a new impeller, install 2 new gaskets onto the shaft threads. The shaft threads should be coated with an anti-seize compound every time the impeller is installed. Do not apply anti-seize compound to the shaft sleeve gaskets or the face of the shaft sleeve. The shell has integral lifting eyes for handling. Mild steel inserts are cast into the shell and drilled and tapped for studs which hold the shell to the pedestal and also to hold the suction plate and liner to the shell. Before installing the shell to the pedestal, make sure that the rabbet fit on the pedestal and the machined surface on the back side of the shell are clean. Either a thin gasket or a thick rubber donut gasket is used to seal the shell to the pedestal. For more information on wet end part replacement or for general pump assembly and disassembly instructions, refer to your LSA maintenance manual.